Good afternoon. So I will be discussing to you the new topic for the coverage of our second quarter, which is for the coverage of the final. We just concluded the midterm exam, so the first topic that will be covered for the second semester, for the second quarter up to the finals will be one of those topic will be the deterministic finite automata, or what we call DFA. Okay, so uh, a quick note before we will continue. I actually discussed this last few weeks with regards to the machine and automaton. We all know that the word machine and automaton are actually interchangeably. You can either use machine or you can either use automaton. And by the way, when we say automaton, it's actually a singular form, because when you say one automaton, that is considered to be singular, and when we say the plural form will be automata. Okay, so again, for one automaton, that is considered to be one machine. For two, that is considered to be automata. Two or more machines. Okay, so uh, the finite state machine automation. So when we say the finite state automation, usually this is the simplest computational machine learning, because it has a limited memory, and it's not that complicated, because from one state to another, you know where to go. That's why it is what we call every state is actually determined. That is what I'm trying to say. So if you have this figure here actually symbolizes that when we say finite state machine or automaton, it is the simplest computational language machine or language automata that is actually has a limited memory. So whatever functions that is being predetermined, that is where bali diha ra siya it will stay with that function only, because finite, meaning to say it has an ending, it also it has a beginning, and it also somehow end at some state. Okay, so let's say for example we have here a simple machine. So for example, an oven, the controller of an oven, so of course it has an on and off. Example, we have a microwave oven, since we're talking about machine or automata. So let's take for example the controller of an oven, which is, of course, it has an on and off, which is considered to be a finite state machine. This controller will have an on and off machine. So let's take for example, this is a brand new microwave oven. So usually the default for that state will be turn off state. So whichever state whatever state that the start will, what we call a start state. Diba katong zero, we have Q0 start. This is a start state, and then when we say that this is a start state, usually there's an arrow pointing at it, right? Just like what we have discussed in the theory of computation last semester. Now when the button controllers is pressed, this one, if this is pressed, automatically it goes into the on state. So it is go into the on state. So again, if the button is pressed again, so it will goes back to the off state. So that how is a simple computational machine, or we call it automata, the design of it. Okay, so let's take for example, now we will go to let's construct a machine that takes a string of weather data as input. Let's say input is a string of weather data, and then tell us whether a heat wave occurred in a given year. So let's take for example, in India, this is what the data is given to you at the screen. So heat wave usually, ma consider na nimo nga heat waves if the temperature is greater than or equal to 45 degrees Celsius. We all know that the higher the figure, or the higher the number, is magkainit na siya degrees Celsius. So the lower it gets, the coldness, the temperature as well. So if the temperature is greater than or less than, or is greater than or equal to 45 degrees for 2 consecutive days, meaning to say there's a heat waves that occurring in the certain place. Now in particular, we're talking about in India. So in India, let's take for example, usually in India they are really they have the most hot temperature there. So particularly in their meteorological department, it considers as a heat wave if the maximum temperature that is going on with the weather there, it is considered to be, for 2 consecutive days, it is considered to be heat waves. So based from the condition definition, we will construct a machine that is basing from this data. So I have saved it somewhere here. Okay, here. Okay, so based from this condition, sorry. So based from this condition, let's say, and I will have to divide the monitor so that you can also identify based from the condition. Where is it? Okay, so the condition, and then the problem is that we will construct a machine that designed to determine if the wait lang. Okay, designed to determine if the place is having or occurring, or something is occurring with a heat wave that is going on with a temperature that is greater than or equal to 45 degrees, that is consecutive with 2 days consecutive. So first is, if we hit a day where the temperature is greater than or equal to 45 degrees, of course the transition into this state, which we will call Q1. So Q0 is the initial state, or we have the start state. And then if the transition is, let's say for example, day 1, it reaches to greater than or equal to 45 degrees, it will transition into the new state, which is considered to be Q1. So day 1, that is a day 1, Q1. And we will call it Q1. Now if we hit another day, and then particularly it reaches into greater than and or equal to 45 degrees, where the temperature is, it reaches the maximum temperature. So the transition into this another state is what we call Q2. So we call it Q2. We call the Q2 the accept state, or the final state, since it represents the accept state. And then we call it the final state because it is also a determining factor that after 2 days, consecutive 2 days, consecutive 2 days, that the temperature is, it reaches the maximum temperature of 45 degrees with 2 consecutive days. Now, we will represent this in another scenario, wherein what if the temperature not reaches into 45 degrees Celsius, or it is less than the maximum degrees Celsius, which is maybe 44, or below 45 degrees Celsius. So we also have here okay, so we also have here this one. No, this one. Okay, this one. So in the initial state, we have here Q0, Q1, and Q2. Now, if the temperature is actually less than 45 degrees Celsius, which is stated here, instead of going to the another state, it will loop into Q0, because as condition, we have the temperature reaches to 45 degrees Celsius. If it is less than 45 degrees Celsius, it will loop in into the Q0. It will not go to the, it doesn't have, or it will, no transition that is happening to another state. So let's say, for example, the next temperature reaches into 45, into greater than 45 degrees Celsius or equal to 45 degrees Celsius. Of course, it will, the transitions will go to the next state, which is Q1. And in Q1, what if in the Q1, the temperature will not reach to 45 degrees, or meaning to say less than 45 degrees. Instead of going to Q2, it will go back to Q0, because the goal for this machine is to reach 45 degrees Celsius to go to the another state. Okay, now the next day it will reach to maximum of or greater than 45 degrees Celsius or equal to 45 degrees Celsius consecutively. So meaning to say it reaches the Q2, or what we call the final state, or the Q state, or the accept state. Now, we all know that if it reaches to the final state, we usually put another circle for that. Meaning to say, you have reached the final state. The final state is already determined. Now, in the Q2, meaning to say, it's either even if the temperature reaches less than 45 degrees Celsius or more than 45 degrees Celsius or equal to 45 degrees Celsius, it will loop in into Q2, because we have already reached the final state. Okay, now we will go back to the PowerPoint presentation. Wait lang. Okay, here. So based from this presentation, we can say that if we will convert this into binary, meaning to say that our machine, which is represented as M, now if it doesn't reaches to 45 degrees Celsius, it is considered to be 0, and if it reaches to more than or greater than 45 degrees Celsius, is considered to be 1. So here, Q1, or we call it start state, if it is 0, meaning to say if it will loop in. Now, if the input is 1, or if the symbol is 1, it goes to next state, or the transition will go to the next state, and so on and so forth. So until it reaches to the accept state. Now, in the accept state, or in the final state, it doesn't matter if the input is 0 or 1, it will loop in on its state, since we have reached, or we have determined the final state already. Okay, and so therefore this figure is what we call a deterministic finite automata. This is what our topic is all about, or we call it DFA, because for each symbol we have 0 and 1 of an input string, because our input string is greater than or equal to 45 degrees for 2 consecutive days. So our input string is 0 and 1, or the symbol is 0 and 1. So we know where to go and what the next state will be. So usually when you say deterministic, every state that we are actually doing, we know where to go. We determine as to what will be the next state. Okay, so we say that automaton recognizes the language. So usually when we say language of the machine, let's say for example, language of the machine is equals to all strings containing 1 or 1, right? Because based from this what we call this, based from this figure, we can identify that the language of the machine is a set of all string containing 1 or 1, because we all know that 1, if it reaches 45 degrees Celsius, 1, and then if that is for 2 consecutive days, so it has to be 1 1, or both binary 1 1. So M recognizes LM. So LM, all strings containing 1 and 1. If we based on this state machine, we can already know that M, or the machine, which is our the one that we construct now, is actually accept 1 1. Of course, automatically it's accept 1 1, and it also accept 1 1 0, as long as ang 1 1 is actually consecutive. Meaning to say, if consecutive na 45 degrees, it is already acceptable. However, if it is not consecutive, wala nagkasunod-sunod, meaning to say, you cannot still reach to the final state. So these are the symbols, or what we call the members of the string that is acceptable. It accepts 1 1, it accepts 1 1 0, and it also accepts 0 1 1 0, as long as it is consecutive, and as long as it reaches to its requirement, which is 45 greater than or equal to 45 degree Celsius. So wait a minute. So this kind of automaton is what we call deterministic automata, or DFA for short. And to formally define the DFA, we use a 5 tuple. You all know what is 5 tuple, right? So we have discussed this already. We have Q, we have sigma, we have delta, we have Q0, and we have F. So this stands for, so when you see Q, it is a finite set of the machine state for our machine. So M, Q would be the set of containing Q1, Q2, and Q3. So Q is the set of states. So we all know from the machine that we construct earlier, that Q is equals to a set of Q0, Q1, and Q2. Now, for the alphabet, which is represented or denoted by a sigma symbol, it is a finite set called the alphabets, right? Which are the kind of symbols that are recognized by the machine. So in this case, it is a set containing 1 or 0. Because we all know that if the condition is if it reaches 45 degrees Celsius, more than 45 degrees Celsius, it is 1. If it doesn't reaches the 45 degrees Celsius, meaning to say less than that, so it's automatically 0. So basing from this machine, in this case, it is a set of containing 1 and 0. Now when we see transition, it is the function of the transition tells us that the delta whose state transitions to given an input symbol. So in this table, we all know, for example, the QO or the Q0, the transition state Q1 when reads A. Let's say, for example, when it reads A and remains in Q0, but when it reads 1, the transitions will go to Q1. But if the transition is but if the value of the symbol is considered to be 0, it remains to Q0, right? Now if it is you have already in the Q1, so usually in the Q1, the transition is from, in order for you to go to the next state, which is Q2, you have to input 1, or else you will go back to Q1. Now in Q2, it doesn't matter because you have reached the final state already. You will always remain to Q2, either 0 or 1. So based from this what we call this, based from this machine. So it can say that the table of the transition functions based from this machine. So Q0, if the input is 1, it will go to the next state. However, if the input is 0, it will loop in, meaning to say 0. Now if it is in Q1 already, if the input is 1, it will go directly to the Q2. Now if the input is 0, it will go to Q1 again. Now if the input is Q2 and it's either 1 or 0, it will loop into itself. So either the input is 1 or 0, it will stay in the Q2. Now the next one is the Q0. So when you see Q0, it is the start state. We all know that it's a start state. And then we have the F is the set of accept or final state. So F is equals to Q2. Okay, so these are the what we called the summary of the tuple figure. So Q is the set of state, alphabets or the sigma is the alphabets, the delta transition is the transition function, the more about the travel from state, and then the Q0 is the start state, and then the F is the accept state or the final state. Now, so let's summarize what we have said in this video. So when you say regular language, a language recognizes by some finite automaton, that is, let's say for example the one that we made earlier, the string containing 11. So this is what the machine looks like if we convert the 45 degrees into its binary conversion. I hope you have understand everything, and then I will give you some learnings that we so far para ma-wrap up lang nato. So DFA is a 5 tuple. So usually when you say deterministic finite automaton is actually composed of 5 tuple, which is we have the Q, we have the sigma, which is the alphabets, we have the transition, which is the delta, and then we have the Q0, which is the start state, and then we have the F, the final state of the accept state. Now if the symbols or members of an input string compose or the machine to be in accept state. So usually when you say deterministic, you will really reach into its final state, and then the final state we usually have the double circle. So if it is not in the double circle, meaning to say you have not reached to its final state or accept state. Now another thing is that the language of the machine is a set of all strings it accepts. Okay, and then the last one is a language recognized by some finite automaton is what we call a regular language. Okay, so I will be preparing an activity for you to work on maybe next week, and then you can submit it in the office. I will just let you know what time. Okay, thank you and have a good day.